Okay. Today we're talking about something that's very close to my heart. It's Tibet. The roof of the world. I had no idea why it was called the roof of the world, but I went home and I looked it up. And apparently, or no, I didn't go home, I just checked on my phone. And I looked it up, and Tibet is called the roof of the world because it's high up there. And it's a plateau. That's why it's called the roof of the world. Either way, it's one of the most sensitive places on Earth when it comes to climate change. It's because it's way high up in the altitude. It has tons of glaciers, and so it's sensitive to climate change. And it also has lots and lots of grasslands. And apparently, as it turns out, there's lots of organic carbon in the soil in these grasslands. And scientists lately have been looking at a component of this soil organic carbon called microbial necromous carbon, which makes up to 87% of the total SOC in grasslands like this. And why is it important? Why are scientists taking a look at this and see the microbial necromous carbon? Well, they're doing so because in sensitive places like this, it's really important that the carbon stays in the ground, because more carbon in the ground, good. Less carbon in the air, also good. More carbon in the air, bad. Less carbon in the ground, bad. Yeah, but either way, if there's more carbon stuck in the ground, then it's good for the environment, and places like this, which are really sensitive to climate change, might give us an idea of how these places are going to react when the temperatures are rising, as they are globally, and it's expected to rise by something degrees by 2050, let's say. I'll put the numbers over there on the screen. Anyway, this microbial necromous carbon is just a fancy term for dead microbes in the soil. And so scientists went out to the fields. They covered around 20 degrees of latitude or longitude. I'm not sure. I should have done my research before I started this, but it's around 2,200 kilometers in like area. And they took samples from a bunch of these different places: steppes, I'll call it steppes, alpine meadows, all of those places in a vast geographical area. And they took samples of something called aminosugars. So these aminosugars, they are, if you look at them, you can sort of look at the amount of microbial necromous carbon in the soil, or the total soil organic carbon in the soil. So they took a bunch of samples of these aminosugars, they quantified them, they also collected a bunch of data regarding the temperatures, the rainfall, precipitation, and a bunch of other factors. And they also, based on some predictions they had idea about what the temperatures are going to look like, what the conditions might be, and they fed all of this info. They also collected like plant matter, because that matters. Because they would matter. Okay, yeah, we're done. Okay, so that was good. Okay, I'm sorry for laughing at my own jokes, but okay, so they collected all of this data, and they sent all of this data out, or they fed all of this data to a deep learning model, which did some processing on it, just jumbled everything out, and then it showed, drum rolls, that the microbial necromous carbon levels on the soil actually are going to rise when the temperature rises, basically. So in 2050, there's going to be more MNC levels in the soil in the Tibetan grasslands than there are at the moment, or that's what the prediction says. And this is fantastic news. This is big news. It shows us that how places like this that are sensitive and critical to our environment, and probably harvest a lot of really good ecosystems that we need for the Earth to function correctly, can adapt to these circumstances and potentially help us fight climate change. One of the approaches the scientists use in this was also they looked at what microbes are present in the soil that they looked at. They did that by collecting 16S rRNA, which is a segment of the gene that's present in almost all bacteria. And by doing that, they looked at, they could identify which bacteria in millions of numbers live in these separate eco-clusters. And by doing this approach, they know which organisms live there, how they might actually change in these different settings based on different conditions and all that. And they also found out that the actual number of microbes grows down in the soil, and their variation, or maybe I should not speak about. So, and they found out that the number of microbes actually goes down. And that was, as far as the authors were concerned, unexpected, because microbes generally like higher temperatures, perhaps not as high as it's going to be, I guess. Or rather, maybe that's a false conclusion that I should not make. But either way, they found out that the microbial necromast levels actually rise up, but the microbes stay low. So it shows a very complex dynamic, because this microbial necromast carbon is just essentially remains of dead bacteria. It shows us how complex this relationship, there's a fly. It shows us how complex the relationship can be in ecosystems like this. The dynamic between microbes, the soil carbon, the plant matter, temperature, precipitation, all of this is a very complex dynamic, a complex relationship that exists between all of these components. And this research, in an article that was published 2 weeks ago, it gives us a really good idea and perhaps a starting point to show and encourage others to sort of see how places like this react. And like, as the results of this study shows, it could be good for us. It could help us fight climate change in really good ways, and it shows us how places like this will have to be preserved, because they are in it together with us. That was my one take mumbly, rumbly, zombly video. I really hope you liked it. It's okay if you don't like it. It's my first one. I'm going to continue making more of these. And this was a really fun talk. Just sitting down here in the forest floor with birds and stuff. You should see this. It's so nice. Oh no, you can't see this. There's like a camp shelter thingy, and that's my bike. And there's some wildflowers. But yeah, I'm just sitting out there in the middle of nowhere, or in the middle of somewhere. And it's good. See you, bye.